Section 2.4 reviews the idea of complex numbers. And a complex number is a number that is written in the format a plus bi, where a is the real part and then b is what's called the imaginary part. We deal most with imaginary numbers when we've got negatives underneath square roots. That's sort of how we rectify our issues with negatives. So when we look at imaginary numbers, a couple things. First of all, when we see an I, does it indicate that it's a square root of -1? That is a true statement. Second fact about imaginary numbers, when you add complex numbers, you add the real part and imaginary part separately. This right here is that complex number, and that is true. If I were to be adding, say, 7 plus 2i plus 6 plus 3i, I would add the 7 and the 6, which gives me a 13, and the 2i plus 3i, which would give me a 5i. Third thing, when you subtract two complex numbers, you change the sign of the real part, but not the imaginary part. That is a false statement. You actually switch the signs of both parts. And that goes back to the basic idea of distributing. If I had 7 plus 2i minus 6 plus 3i, that -6 gets distributed to both pieces. And then I would simplify down. This right here, 2i times 4i squared is equal to 8i cubed, is fully simplified. Well, that's a false statement, because I cubed, we actually know, is going to be a -I. And we'll talk about that in a moment if you don't remember that. I cubed is -I. So this actually simplifies down to -8i when we're fully simplified. The product of two complex numbers will sometimes yield only a real number. That is a true statement. And then finally, the last part right there, it says the first step is correct in simplifying. This is a false statement. When we want to simplify complex numbers, we've got to use the conjugate. And the conjugate is where you switch the sign of the imaginary piece. You don't multiply by the same thing again. This needs to be 3 plus 7i by both the numerator and denominator. So with these complex numbers, a couple of things you want to know about the pattern of complex numbers. The first is the pattern of i's. The first is that I to the first is equal to I. I squared is equal to -1. I cubed is equal to -I. And I to the fourth is equal to +1. When we simplify, we should not have I squareds, I cubes, I to the fourths, I to the fifths left over. We want to have everything in terms of i's. And the pattern continues along. I to the fourth is 1, then I to the fifth is I to the sixth is -1, I to the seventh is -I. Just keep going through this pattern of I, -1, -I, and 1 continuously. So let's begin by just doing some basic simplification. Here we've got 2 plus the square root of -25. And we can rewrite the square root of -25 as 2 plus the square root of 25, the square root of -1. And when we write it like that, we can see the negative square root of 1 is I, square root of 25 is 5. So this simplifies to 2 plus 5i. The second one, that's square root of -77 squared plus 17. Well, the square root and the square cancel each other out. So I'm left with a -77 plus 17, which gives me a -60. The third example right here, the square root of a -2 times the square root of a -24. Same thing is true in terms of how I can rewrite this in terms of positive square roots and negative square roots and simplify down to I. This right here is the same thing as square root of 2 square root of -1 times square root of 24 over square root of negative 1. So this here is actually going to be I square root of 2. We put our constants out in front with I, because if we put it in the back, it looks like it's underneath the square root. The back piece right here, that 24, simplifies to 2 square root of 6. So I'll bring that I out in front as well. So it's 2I square root of 6. Now as we go along and simplify, we multiply outside square roots and then inside square roots separately. So I times 2I is 2I squared. The square root of 2 and the square root of 6 is square root of 12. This we can continue to simplify a little bit more. The square root of 12 simplifies down to 2 square root of 3. So if I have 2 square root of 3 times 2I squared, I've got 4I squared, square root of 3. And then the final piece, we know that I squared is equal to negative 1. So this is really a negative 1 times 4, which is negative 4, square root of 3. The fourth example that we have right there is some foiling that we're going to do. And before we FOIL it out, we want to write this in terms of imaginary numbers so we don't start losing properties with these negatives underneath square roots. So the first piece right here, the square root of negative 7, is going to be 2 plus I square root of 7. We like putting that I out in front. And then the second piece right there is going to be 3 minus I square root of 30. So we'll make a little note right there that we're going to FOIL after we rewrite it. So first thing we do is we convert our negatives underneath the square roots into the I format. When I do that, I can now do FOIL. 2 times 3 is 6. The outer, 2 times negative I square root of 30 is negative 2I square root of 30. The inner, I square root of 7 times 3 is 3I square root of 7. And then the back, I square root of 7, then negative, or the I square root of 30 is negative I squared square root of 210. Now we can combine like terms and simplify. And really here I can see my I squared is going to be converted to a negative 1. So I've got 6 minus 2I square root of 30 plus 3I square root of 7 and then plus 1 times the square root of 210. And then finally the last one is an example of using the conjugate. When we want to get something out of the denominator, we multiply both the numerator and denominator by the conjugate. So 3 minus I, the conjugate is 3 plus I. So at the top, we'll FOIL out 3 plus I with 3 plus I, which is going to give us 9 plus 3I plus 3I plus I squared. The denominator, I've got 9 minus an I squared. We know that that I squared is equal to negative 1, so 9 minus a negative 1 is actually 9 plus 1. And in my numerator, I've got 9 plus 6I minus 1. When I simplify, there's that I squared again being a minus 1. Combine my i's there. So then I've got 8 plus 6I over 10. At this point, we're almost fully simplified. Out of the numerator, we can pull out a 2. And then my 2 and my 10 will simplify down to 1 and 5. So 4 plus 3I over 5. So this section is just reviewing the basic concepts with imaginary numbers and how you simplify with imaginary numbers.